So now on the analytics pane, we will try to explore certain options where you can do more than what you saw in case of the data pane. Where in the data pane we were focusing mainly upon the visualizations and working upon some calculations. The analytics pane provides you with certain options that you can readily use, and you can perform a detailed analytics onto the data. And especially for people belonging to the data science field, this is very intuitive because this is something that will allow you to build some sort of predictive models as well, where you have certain options related to regression, clustering, as well as time series forecasting. So we'll be trying out all of those options today, and we will be seeing how we can make use of analytics pane and Tableau in order to analyze and build predictive models onto our data by just simply dragging and dropping things without having to write those lengthy codes that you would usually write into a tool like Python. So let's get started with that. And the very first thing that I would like to show you is the time series forecasting, because the data that we are already connected to, the sample superstore data, has the date related variable, right? And when it comes to time series forecasting, where you talk upon things like, what could be the gold prices for the next 6 months, or how will my company's revenue look like for the upcoming year, or let's say how are the stock prices going to fluctuate over the next 2 weeks. When I want to look at such kind of insights, that is where the time series forecasting or the time series modeling domain comes into the picture. And let me tell you that Tableau allows you to build those time series models which will enable you to forecast into the future, and it uses the exponential smoothing models for now. So in case you want to build some sort of handy models that will allow you to forecast into the future, you can do that using the exponential smoothing approach that Tableau follows. So how do you do that is what we are going to see now. And you can see that I am onto a fresh sheet right now, where I'll just try to firstly build a graph where we will try to let's say analyze how over the period of time my values have fluctuated. We have the revenue that was generated, right? The sales variable that we had into this data. We can try to visualize it over the period of time. We did it in the past sheet. We can probably try to see where is that sheet that we had created. But we tried to modify that sheet, and we tried to make some changes over there in order to look at the data in the form of different years, and then also for the different categories. Yes, this was the sheet that we had created where we did apply the line graph in order to visualize the data over the period of time. Let's try to create something similar so that we can go ahead and apply the time series forecasting model onto it. So let me pick up the variable once again. We will again pull up the order date variable, because this was the date when the revenue was generated. And you can see by default, given that Tableau uses its inbuilt hierarchy, you can see it has been aggregated to the yearly level, where you can see we have the data from 2021 to 2024. But if we want, we can try to drill this down further in order to see the data in the form of quarters or maybe months. It's up to us what level of granularity we would like to have in the data. Now, along with this, what I would like to visualize is the sales, given that that will be the target variable or the variable of interest in this case. And you can see again, I see those declining kind of trends, but that is only because the axis has to be reversed yet, right? Let's swap the axis and we will be able to see the right kind of a graph. And you can clearly see now that I have the timeline on the x-axis and the sales value, the variable of interest, on the y-axis. Let me just roll it up to the quarterly level rather than keeping it at a monthly level, because the monthly trend is not very clearly evident in this case. So let me do it at a quarterly level, and this is the kind of graph that we have present in front of us, where what we observe is over the period of time from 2021 to 2024, the sales have increased over the period of time, and you see that there is a kind of seasonality pattern that we observe here, that every year the sales are at a lower end in the beginning of the year, and they spike up in the later of the year, right? Because probably there are certain sales that might be spiking up due to the Christmas season, correct? So that definitely is a kind of seasonal pattern that we can observe over here. So people who are aware of time series forecasting might be aware of those two important components that we look at in the time series data. First one is the trend, which, as I told you, I see that it is increasing in an overall fashion. Let me show that to you by converting this kind of a graph. Yeah, to the continuous line graph, and you can see that compared to the 2021, our sales are increasing in the year 2024. So trend is something that is seen over a longer period of time, and you can see that it is slowly increasing. So it's a positive kind of a trend that we see here. And the second major component is the seasonality component, which is where we talk about some repetitive patterns that are, usually seen over a shorter period of time. For example, in our case, as I mentioned some time back, there is a yearly pattern which we see, where in the initial months of the year the sales are comparatively on the lower side, and then they spike up towards the end of the year. So now that we have this data, let me convert it back to the discrete line graph. Okay, so now that we have this data present in front of us, let's try to apply time series modeling onto it. So sometime back when we looked at the analytics pane, everything was disabled, right? But now can you see all of those things which are applicable to this data have been enabled for us, and we can easily use those things to be applied onto this data. So currently, as we are discussing about time series forecasting, let me try to drag the forecast option and drop it onto this graph such that it will be performing the time series forecasting model for me. And there you go. This is where we have built a forecasting model, and we have also forecasted for the year 2025. So this is the forecasted line that we get to see, and if you hover over it, you can clearly see what could be the value in the quarter 1, quarter 2, quarter 3, and similarly in the quarter 4. You also get a kind of shaded region, which is like the 95% confidence interval band, which states that your values could be fluctuating in this shaded region. And you can clearly see that this band is quite a heavy range right now, only because it's not very confident that this values that it has considered as the predicted values for quarter 3 and quarter 4 will remain the same. So there is a high chance that they will fluctuate a lot. So of course this is the default model that it has built, and we can definitely try to improvise this, but let's see how we can do that. Okay, so currently what we will try to do is, we'll firstly try to observe what it has predicted for us. So I'm just right clicking onto this predicted line that it has forecasted for us, and I'm trying to go to the forecast menu. This is where you have certain options with respect to describing the forecast or changing the forecast related settings. Let me firstly describe the forecast for you so that you get to see certain values related to the time series model that it has built. Now if you observe here, this is the summary of the forecasting model that it has built, where it is telling us that the data was present in the form of quarters. We were looking at the sum of sales, and the forecast that it has done is for 5 quarters. Now ideally it forecasts for a default duration of 1 year, which means it should have forecasted for 4 quarters. But there is something that it has set to ignore last. So it is ignoring the last 1 quarter of 2024, and I'll tell you the reason why. And that is the reason the total forecast that it did was for 5 quarters. Okay. And this again are certain values that it is observing as part of the data, and it is mentioning it to you over here, which will enable you to easily copy this to the clipboard and use it into your documentation. And this is really a good thing about Tableau, that it gives you some ready-made documentation created. All you need to do is copy and paste it. Similarly, you also have the models tab where these values are indicated to you, which talks about that this forecast was done using exponential smoothing. As I mentioned, it uses the exponential smoothing models behind the scene. It has built a multiplicative kind of a model. What were the values for the various parameters like alpha, beta, gamma have been given to you over here. And based on this model, what is the root mean squared error, the mean absolute error, all of these errors and the AIC value has also been given to you. So these are just some detailed insights based on the model that was being built here. And we can easily again copy this as well to the clipboard to be included into any other documentation. So that's something that you get as part of the describe forecast, which talks about the overview of the model that has been built. But let me also show you how you can modify this forecast. So again, when you go to the forecast menu, you will see there is a setting called as forecast options. And this is where you will get this kind of a dialog box wherein you can set certain options such that it modifies the forecasted values as well as the period for you. Now, if you observe here, the forecast length by default is set to automatic, which as I told you is 1 year duration. But it has automatically forecasted for 5 quarters as we read in that describe forecast. And why is that 5 forecasts being taken here, or let me put it this way, why are those 5 quarters being taken here for forecasting? That is because the ignore last was set to 1. And now what is this going to indicate here? So let's assume a scenario that I am into the quarter 4 of the year, okay? And if I talk about quarter 4 being, going on currently, let me tell you one important thing, that in this case, I am assuming my year is starting from January to December, and I'm not considering the actual fiscal year, which is from April to March, okay? In that case, I would still be in the quarter 3, correct? But if I say that I am into the quarter 4 right now, let's consider I'm talking about the year starting from January and ending in December. So now let's assume that I am in the month of October. What happens is I have already entered the 4th quarter. But do I really have the data for the entire 4th quarter? The answer is no, correct? Because there is still November and the December months to be completed. So when this is the kind of a scenario where you have already entered the quarter 4, the Tableau environment will find the values for quarter 4. But it does not have the entire set of values for the quarter 4, right? We still have to gather the values for November as well as the month of December. So in such cases, what we can do is we can ignore last as 1 quarter, which tells the Tableau environment you ignore the data for the last quarter, consider the data only till the previous quarter, and then you build the model, because we don't have the entire data for the last 1 quarter. In case you don't have the data for the last 2 quarters, you can feel free to set it to ignore last to 2, and you will see it will ignore the last 2 quarters and then predict accordingly for you. But for now, let's assume that we have the entire data, because if you remember when we looked at the data source and we saw the values that were present in this particular file, we had the data till the 30th of December 2024. So this is a manipulated data that Tableau has created. So we have the data for the entire year. So I don't need to really ignore any of the quarters as such. So suppose I set it to 0, you can see my forecast has now slightly been modified. We have the values being taken into consideration till the end of 2024, and now it is predicting for me for the year 2025. So now that this is done, I can try to modify certain other things as well. Let's say, for example, I don't want to go by the automatic mode of, the forecast length. I rather would like to mention that I want to forecast for not just 1 year, but 2 years. And it will do that for you. You can see the changes happening in the background, correct? Or maybe you can also change this to certain number of quarters or certain number of months. So let's say I want to forecast for the next 6 quarters. Okay. So let me just change this years to quarters, and you can see this is the kind of change that you get to see, where the 4 quarters for 2025 and the remaining 2 quarters for 2026 is what have been predicted. So it's up to us to decide how much duration should we try to forecast for. So once that has been decided, for now I'm sticking to the default 1 year of forecast, because usually exponential smoothing models are not used to, forecast for a very long time period, given that they are more suitable for shorter term forecasts. Okay. So I'm sticking to the default 1 year of forecast here. And you can also see there's an option to fill in the missing values with zeros, which of course I wouldn't want to do for now, but you have that particular option. And there are a couple of forecast models which are available where, the default, the automatic one is the best one, because in such automatic models, it tries to identify the trend as well as the seasonality automatically in your data and decides which model will be suitable. The time series forecasting that we do using exponential smoothing can be done using 3 different models. One is the simple exponential, one is the Holt's linear trend model, and the third one is the Holt winter model, which is suitable for data where there is seasonality present. So automatic will give the liberty to Tableau to decide which model will be more applicable or suitable, and it will try to apply that onto the data. So we have selected the automatic model here, and let me also show you that there is an option to decide what should be the prediction interval. The default one that they set is the 95%, which is the standard that is used in the industry, which says that 95% of the time your values will lie into this particular range. But you can feel free to set it to 90% or 99% depending on the requirement, and you can modify it accordingly. So let's say if I go as per the 99%, you can see the band is expanding furthermore. And if I set it to 90%, the band is lowering down a little bit, because whatever we are stating is with 90% of confidence. The remaining 10% of the time there could be an error. So this is the kind of changes that you can make when you are trying to build a forecasting model in Tableau. So now that I have made the required changes, you can see by default automatically it is predicting for 1 year, which is the 4 quarters, because I have set the ignore last to 0. So once all of these settings are done, let me click on OK, and yes, this is the forecast that I have got. Now, just to tell you a little bit more in terms of this model, what we have got over here are the values, correct? Which is for the quarters, because we had the data organized in a quarterly format. If you try to drill it down to the monthly level, we will be able to get those values at a monthly level. As simple as that. But there is even more complexity that we can end up adding on to this data. For example, currently we are looking at the overall sales of the superstore, right, which was happening across this 4 years of period. But what if I want to do something like we saw in the previous sheets, where I want to break this down on the basis of different categories? I can easily do that by dragging the category variable and dropping it onto color, or maybe I can drag the category variable and even place it onto the rows over here, such that it breaks down this entire graph pane wise. Now this makes it more sensible, right? We have got 3 different panes for 3 different categories, and you can clearly see the forecasts that are being done for those different categories of products. So we can see that for furniture, the sales are almost going to be constant from quarter 1 to quarter 2, but they are definitely going to pick up in the quarter 3 and quarter 4. For office supplies, your sales are going to increase from quarter 1 to up to quarter 3, but slightly decrease in the quarter 4. And for technology, quarter 1 to quarter 2 is going to be almost a stable one, and will again increase from quarter 2 to quarter 4. So these are the kind of forecasts that it has done for the year 2025 based on category. Now imagine you having to do this onto a tool like Python. You would firstly have to divide the data based on each of the category, and then go ahead and build 3 different models, one on the furniture data, one on the office supplies, and the third one on the technology related data, correct? But here in case of Tableau, it is as simple as dragging that category variable and placing it over here in the rows, and it divided your data and build those 3 models, and you're ready with the forecasts within seconds. This is the power of Tableau. And this is very, very important that, non-technical people who are working on to such kind of tools leverage the benefit of using statistical models and present their data more meaningfully to the audience. And that's where the analytics pane definitely becomes useful. Just to, beautify this entire thing, you can also label in order to show those values that it has predicted. But again, having said this, this is just a visual, right? When I present this information to the audience or to the manager, I would definitely want to show this image as well as a tabular report, such that those values make sense to the manager, right? Just by looking at the graph, it would be difficult for him to relate to the values. So what we can do over here is, this is just like any other worksheet now, correct? So I can go to the worksheet menu, I can export it as a cross table to Excel, and it will do the task for me. I don't have to manually create a pivot table kind of a structure. Tableau will automatically do that for me, and all I need to do is present. So if you look at this output that Tableau has generated, you can see I have the category wise data divided for furniture, office supplies, and technology. What we are trying to look at is the sales value. So you can see the middle row over here has been populated for the year 2021, 2022, 2023 and 2024, because those were the values that we had. And ahead of that, what we have done is we have tried forecasting for the year 2025. So the values have been populated for the sales row as well as the lower prediction interval and the upper prediction interval, which is nothing but the confidence band. So this value over here and this value over here has also been given to you in that cross table. Isn't that interesting? So you get those values in a tabular report, which can be forwarded to the client or to the manager, and he can actually look at those values and make sense. So visual representation is one part of it, but this cross table in Excel is definitely make more sense to the audience. So this is how you can perform time series forecasting in Tableau, and currently it just supports the exponential smoothing approaches. It does not support your ARIMA models or any other kind of approaches, but this is definitely a handy approach when you want to quickly perform some sort of forecasting and display it to the audience, and at least some initial insights is what you can derive out of this forecasts in order to plan your strategies in a wise manner. So that's about the time series forecasting in Tableau. Now that we have seen how time series forecasting models can be created in Tableau, let's try out some other example, because we still have the regression model as well as the clustering models that we can try out, correct? But for this, I'm going to require some other data. So let me do a quick thing. I'll just try to connect to some other data sources from within this file itself, okay? So just to tell you about how to connect to different data sources, now that I'm onto the data pane, all I need to do is click on this new data source icon here, and this will give me the connect pane which we get on the home page. From here, I can select, whichever type of file I want to load. So let's say I have a file with me which I'll be using in order to show you how to perform the linear regression. So this salary data file is what I'm going to make use of, which is a CSV file. Now just to make you understand what is this data all about, we have the years of experience that an employee carries versus what is the salary that the employee is drawing. Now based on this data, it's a very simple data that I have taken in order to help you understand how regression can be performed onto this. We are just going to take the years of experience as the X variable, and salary is the value that we will try to predict given the experience of the candidate, correct? So this is the data that I'm going to load now into Tableau, and while you try to do that, all you need to do is establish a connection through the Excel file. Establish the connection through the CSV file. Now, in order to connect to the CSV file, you need to select the text file option. And this is where you will end up getting that data, which you can just double click and load here into the Tableau environment. And you can see that I am onto the data source pane, where I have this data pulled up correctly. And when I say correctly, what I mean is the data type is numeric, right? We see hash as the sign. So it means that the data type is numeric here. We have the years of experience and the salary as the two variables. I'm fine with this data. So let's go on to the sheet. I'm going to a fresh sheet right now. And you will see that I get to see two data sources listed here. When I click on salary data, I get to see the variables which were present in salary data. And when I click on sample superstore, I again get back those variables that we were working upon so far, right? So within the same workbook, you can establish different data source connections and still have them separated as individual data sources and collate just the information together to put into a final single story. So let's have a look at this data over here. I have the years of experience which I'm pulling into the rows, and I have the salary which I'm trying to pull into the columns. So this is where this is the kind of graph that I've got. Now, first thing is that I wanted years of experience to be on my x-axis, based on which I'll try to predict the values for my salary, which goes on the y-axis. So I definitely need to swap the rows and columns here. Okay, now that I have done that, you can see that I am actually getting a single point, and that is because, as we discussed some time back, that by default Tableau tries to associate the sum as the aggregation measure for any continuous numerical variable that we pull up into the data. That is the reason why we are getting a single point, because sum of years of experience give me a single value and sum of salary again give me a single value. So just locating the x and y coordinates, I get that single point here. So now, in order to get a scatter plot, in order to understand the relationship between the years of experience and the salary that they are earning, we need to ensure that this is not an aggregated plot but a typical scatter plot. And how do we create a scatter plot? If you remember, we can go to the analysis menu and just uncheck the aggregate measures. And you can see these are the points that we have individually into this data. So if you see very few points into this data, a small data set is what we are looking at. But while you look at this graph, you immediately can relate to this point that there is a positive kind of a relationship that we see between these two variables, right? And when I say positive, what I mean is, as the years of experience increase, so does your salary also increase. So that's where we call it a positive relationship. You can also see that the points are pretty clustered to each other. So this is a kind of, strong positive linear relationship, because we can imagine a straight fit line fitting into this set of points, correct? So this is the kind of relationship, a linear, strong, positive relationship that we observe between these two variables. So with this data, let's try to perform the linear regression model. So I'll again go on to the analytics pane, and you can see the forecast option is now disabled. Why? Because there is no date related component here, right? So time series forecasting can't work. But trend line is an option which is definitely available, and this is the one that will allow me to perform regression. Can you see? There are multiple options related to regression that it supports. Linear regression, logarithmic, exponential, polynomial regression, and also the power regression. For now, I'm going to drop this onto the linear regression, because I assume that linear regression will work better onto this data because the relationship was linear. And there you go. You have performed linear regression and you have got a best fit line fitting into these data points. So when you hover onto this line, what you end up getting to see is the equation for this best fit line. Those who are aware of linear regression might be aware that there is an equation for the line which states y is equal to your beta naught plus your beta 1 into x, where your beta 1, the value that we see over here, which is 9449, is the slope coefficient for the x variable that you have, whereas the 25,792, the value that we see for the beta naught, is going to be the y-intercept that we have. So the beta naught here is telling me that even if, the experience of the person is going to be 0 years, he is, entitled to get some sort of salary, right? And that salary will be the 25,792. Whereas 1 unit increase in the experience, let's say my experience increases from 2 years to 3 years. That's a 1 unit increase that I see. If that 1 unit increase is happening, my salary is going to increase by 9,449. So this is the change that will be happening in the salary variable with a 1 unit change in the experience variable. This is what the equation is about. And the R square value is going to tell me about how good is this model, how well is it able to predict the values for this data. The value is 0.95. It ranges in the range of 0 to 1, and 95 means almost 95% correct predictions is what we are getting here. And the p-value is less than 0.05 in this case, which means that the variable years of experience that we have considered in order to predict salary is an important variable. There is a relationship between the years of experience and the salary, and hence we are able to predict it 95% correct. So this is what we can infer out of this equation and the tooltip information that we have got here. But just to add on to a couple of more things, we can right click onto this best fit line and we can see in detail about the rest of the things. For example, describe the trend line gives me a short table where it will give me that equation and will also tell me about the values that are present for the variables that we have got. So this is nothing but your beta 1 and this is nothing but your beta naught in the equation. This is how the entire equation looks like. Now, this is what is done by Tableau with respect to linear regression. It gives you the equation, but it does not do predictive modeling for you, as in it does not predict the values for the unseen data. What you will have to do is, you will have to use this equation maybe into a tool like Excel, where all you need to pass is the years of experience and you will be able to see what would be the salary for that individual. So suppose if the experience for an employee is 7 years, I just need to pass 7 over there in the equation and the value for the salary will be computed. As simple as that. So this is how the linear regression can be performed in case of Tableau. And you can also observe that there is a copy button available which will allow you to copy this to the clipboard in order to insert it into any kind of documentation. Apart from that, you also get the detailed trend model. So let me describe the trend model, and this is the detailed information that you get to see along with the errors like the sum of squared error, the mean squared error, degrees of freedom, your R square value, all of that is included here. And this output is more or less similar to the output that you get to see when you are building a linear regression model in Excel. So you can again copy this information and you can include it into your documentation. So this is the benefit of trying out the linear regression using Tableau, because this is the benefit of using the trend line model into Tableau, because you can easily build a linear regression model and you can analyze the equation and work upon it without having to write those lengthy codes in Python or any other programming languages. But having said that, let me also show you that you can edit the trend line. So currently we had built a linear regression model because we could clearly see a linear relationship between the data points, right? But there are other models also which are available, like the logarithmic model, but you can clearly observe that it is not suiting the data points very effectively, isn't it? So if we just go with this, you will see that the R square has now lowered down from 95 to 85. So this is definitely not the model that we would want on this data. Similarly, there are some other models also available. Let's see if it actually suits our data points. Exponential. Okay, this does suit a little bit. So I'm expecting the R square value to be on the higher side there. We have the power, which again does not suit the data points very well over here. We also have the polynomial, which is like a non-linear kind of a regression, and we can just probably check the R squared value for each of these models, and we can fix upon a particular model. Linear regression could also be a good choice, given that 95% was the R square value, and it does pretty much fit the data very appropriately, correct? So we can stick to this model. There are also options that allow you to show the confidence band. So in case you want to include the 95% confidence band, feel free to select this option, and you can see this is the confidence band that you get to see for the best fit line that it has fitted into your data. You can also force the beta 0 to pass through 0, but that will shift the indentation of your line, right? And it may not be the optimum or the best fit line that you get. So usually forcing the y-intercept to pass through 0 is not something that is advised. So I'll uncheck that. And yes, this is the model that we have built, where we have applied the linear regression onto this data, and using this equation, all I need to do is pass the years of experience, and I'll be able to predict what could be the salary of that employee. So without having to write lengthy codes, I could perform linear regression using Tableau, right? But having said that, let me also mention that a model that I would ideally build using a tool like Python could be more effective than a model that I'm building using Tableau, because if you are aware, linear regression is a parametric method, which means there are several assumptions to be checked when you're building a linear regression model, and Tableau definitely does not check for those assumptions as such, right? It just takes the data and tries to fit the best fit line into it. So where you would build a model yourself using Python, you would definitely get the scope to check for several assumptions before you build the model, and then use that equation in order to do the predictions. But with a short span of time, when you want to create a good model, Tableau can definitely be handy. And not just that, you can also try to insert some sort of constant lines or average lines into the data when you want to, let's say, highlight a specific points when you are trying to give the presentation. Let's say, for example, I want a constant line to be added for the years of experience. I can drop it onto this part over here, and I can mention where do I want the constant line. Let's say I want it at 6 years. Can you see I'm getting a vertical line over here at 6 years? And similarly, if I want to drop a constant line onto the other variable, which is salary, I can put it wherever I want to. Let's say I want it at 80K. I want to highlight that particular value. So 80K, I need to pass 80,000 as the value, and you can see the constant line has been generated over here. Apart from that, you can also try to add an average line, which will find out the average of both the variables, experience as well as the salary, and it will try to give you that average line. You can see this is where the average lies. The average salary is 76,003, and the average years of experience seems to be 6. So this is the use of the average line, and you can do this with the 95% confidence interval as well. So if you try to drag and drop this over here, you can see that confidence interval bands have come along with the average lines that you have tried using into this particular graph. So this is how you can perform the linear regression or different types of regressions onto the data, but it is typically useful when you are working on to simple linear regression kind of problems, and less amount of data without doing any sort of assumption checks and all. So that's about the linear regression. And because we are also working upon continuous numerical variable, I would like to show you how you can build box plots onto the data. So let's say, for example, I am trying to drag the salary, and I'm trying to uncheck the aggregate measures here so that I get to see a simple scatter kind of a plot just for the single variable though. I can go on to the analytics pane, and I can drag and drop the box plot now, because Box plot is a kind of graph that allows you to not only see the distribution of the values in a single numerical variable, but it also allows you to detect if there are any kind of outliers in the data. So any points that are going beyond your whisker lines over here or above this value, those are going to be the outliers or the extreme values, and you can definitely get rid of them such that your rest of the analysis is unaffected. So you can create box plots as well with the help of the analytics pane. The only requirement is that you need to have a continuous numerical variable to apply a box plot. So that is also possible, and we did not try it out on the Superstore data. So I thought of taking this opportunity to show it to you now. So that's about the regression that we can perform with the help of Tableau. And what we are left off with now is the last model, which is the clustering. And in order to perform clustering, we'll again, load up some other data, and I'll try to show you how easily we can create clusters into the data. Okay, so let me go on to the data pane once again. And we are currently connected to two data sources here. Let's try to connect to the third one. The third one is also a kind of CSV file where I'm trying to load the iris dataset. I'll talk upon this dataset so that you get a rough idea about what it is related to. Iris dataset is one of the very popular datasets in the world of machine learning. It's a manipulated sample data, but this is very popular because a statistician, Fisher, had used its dataset in his research paper, and it's a multi-class classification kind of a data, has very few set of observations, numerical variables as such, and no missing values and all. So it's a clean data to work upon to immediately build a model. Okay, so just to highlight what are the kind of details present in this data set, you have the ID, which is nothing but a row ID, which can be ignored. You have the sepal length, sepal width, petal length, and petal width as the four variables given to you, where sepal and petal are the parts of the flower, and you have been given their lengths, based on which you need to classify that iris flower into either of the three species. So there are three species for that flower. One is the setosa, the second is the versicolor, and the third one is the virginica. So there are three species of the iris flower that we need to categorize this data into based on the sepal length, sepal width, petal length, and petal width. Okay, so using this data, we will try to implement the clustering model, where I will try to simply divide this data into multiple clusters based on whatever is their length and the width. Okay, so let's move on to that. So let's try to have a look at the variables which we have. So I'm just trying to drag the petal length and the petal width over here, and you again see a single point, right? Let me just uncheck the aggregate measures so that we get a typical scatter plot. And yes, this is the scatter plot where I can now easily go and apply the clustering model. Now, when I drag the cluster model onto this data, remember that I am only using the petal length and the petal width while building this model, okay? But I do have the liberty to add the other two variables also into the model, because while visualizing the data, we are restricted to use two variables because there is an x-axis and there is a y-axis, correct? But when it comes to building the model could definitely have more than two variables. So if you wish to add those other two variables also, feel free to drag and drop them into this clusters window, and it will be able to use that information as well in order to get you those optimum clusters. But for now, I am fine with this very basic model, which is just relying on the petal length and the petal width, so that only those two variables are a part of the model as well, and we are able to visualize the data also on the basis of those two variables. And the number of clusters, this is where let me highlight that Tableau works upon k-means clustering, where you need to pass the value for k, which is going to indicate how many number of clusters you would want to create into the data. So where you are working upon a data and the value for k is not known, we usually leave it to the system to decide upon what could be the ideal value. So Tableau has automatically detected that 3 would be the optimum value for the K, and that is the reason it has divided my data already into 3 clusters. But suppose if I want to pass some other value for K, let's say the client has told me that there are 4 species of flower and I want to divide them into 4. I can specify the value manually as 4, and you will see it automatically ended up making those changes to the graph. You can see there are 4 clusters now instead of 3. But did you observe, automatically it created 3 clusters and we also had 3 species of the flower, correct? So this is where Tableau can quickly cluster the data. And just to tell you, clustering is ideally a technique which is based on Euclidean distances, where it tries to identify the similar data points based on the Euclidean distances. If the data points are pretty close to each other, it is assumed that they are actually going to belong to a same category. And if they are far away from each other, they belong to 2 different categories. This K-means clustering technique that the Tableau environment uses is heavily implemented in the customer segmentation kind of problems that are solved in the industry. So it's definitely a very handy approach when you have a lot of data, you have very little time in hand, and you want to build an effective model to see how the clusters get created, such that you can target those different segments of customers in a different manner by offering them different scheme or different offers, and ensure that you are able to retain those customers with you. So this is where we have tried applying the time series. This is where we have tried applying the K-means clustering model onto this data. In order to get some more insights about this model that it has built, you can go on to this cluster and you can go to describe clusters. This is going to give us that page where you will get to see some other detailed information, which you can again easily copy to the clipboard and paste it into your documentation. Now what I want you to observe over here is certain details, like there were a total of 150 data points which have been clustered into 3 clusters. You have certain error values given to you over here, like the between the group sum of squares and within the group sum of squares. The summation of both of them gives you the total sum of squares. It also tells you that there are 50 data points which have gone into the cluster 1, and you can clearly see this cluster was a very clearly separable kind of a cluster, right? So all the 50 points that were belonging to one of the species of the flower have been clustered very well. But if you see for the cluster 2 and cluster 3, they also actually had 50 data points as per the actual data. But if you see the number of items that have gone into cluster 2, it says 52. And the number of items that have gone into cluster 3, it says it is 48. Which means there are some, misclustering that has happened between the cluster 2 and the cluster 3. Ideal value should have been 50 for each of these clusters, given that there are 50 records for each of the flowers in the overall actual data. But there is some mistakes that has happened because both of these clusters, if you see, the cluster 2 and the cluster 3 were kind of overlapping in nature, correct? So that is where there are chances that there could be certain problems that could occur. And this is nothing but the cluster centroids, where you can see the x coordinate and the y coordinate for the cluster centroid values. Now there is also a models tab which will show you a little bit of analysis. Let me just try to reduce the size here. Yeah, this is the analysis of variance, where it has performed the ANOVA test and given you the results. Again, this information can be used into your overall documentation. So this is where you can make use of the K-means clustering model. And in case at a later stage you also decide to add more variables into the model, you can easily go to edit clusters and you can drag the other variables that you would like to include. Let's say I want to just include the sepal length. At a later stage I decide to also include the sepal width. I can drag and drop, and accordingly some changes will occur in the model that it has built, and it could give us a good or a bad model. That depends upon whatever is the outcome. For now I would like to keep only the sepal length and For now, I would like to keep only the petal length and the petal width, and I would just like you to, try out the same thing manually, because if you remember, our data did have the actual values over here, isn't it? So we can use this variable in order to see what was the actual data going to look like versus what is the data that the model has built for us. So let me just quickly do that onto a fresh sheet here, where I'll just drag the petal length and the petal width. I'll again uncheck the aggregate measures to get that proper scatter plot. And currently you see all of the values are in blue color. I will now drag the species variable and drop it onto color such that I get a similar graph to what I've got in case of the k-means clustering model. And can you observe, I'll just toggle between the two sheets. Can you see almost similar kind of colors is what you see here. Of course, you can change the colors to make it more informative, but these are certain points over here, the overlapping points between the two clusters that have probably got misclustered. But for the rest of the points, it has done a fairly good job for us. So without having to do any kind of coding, we could easily just simply drag and drop the cluster option, and we could build a predictive model here which has clustered the data for us. Alright, so this is where it has clustered our data into the 3 clusters and provided to us, where we can now individually deep dive into each of the observation and plan our strategies differently for the 3 clusters and target the audience more effectively had this been a customer segmentation kind of a data. So that's about how we can perform clustering in Tableau. And this is where we can conclude upon the analytics pane, which allows us to perform some quick modeling onto the data. Although there are more machine learning models that Tableau is trying to integrate. So they are trying to work upon certain models related to decision trees, which can probably help us build a decision tree and visualize it within the Tableau environment. But these are the 3 models related to regression, time series and clustering that Tableau supports for now, which we can effectively use as part of our day-to-day routine, and we can perform some quick analysis and generate the required results onto our own data. So that's it. We have explored the data pane as well as the analytics pane of Tableau, and I hope you guys had a great time learning Tableau along with me. Do try out Tableau onto some other sample data that you can easily download from any of the open source websites, and try to explore the different graphs and charts so that you can try learning how to analyze the data, asking the right set of questions, trying out the different types of graphs to understand and apply the right kind of graph onto that data. And in case you have any more questions, feel free to drop them into the comments section. Thank you all.
Like this video, subscribe to our channel, and comment on the concept you want to learn next.